Hello, thank you for joining us today. We are going to present the propensity model we've developed for National City Bank's new product, a line of credit against a household's used car. We're also going to present 100 prospective customers that our model identified as having the highest probability of accepting an offering of the new product. The presenters include Lizzie, Christian, Daniel, and myself, Ife. The scope of the work we did included exploring the historical data that has been gathered thus far in the pilot phase of the product, modifying that data with supplemental data available, sampling the data to create our model, and analyzing the model's KPIs. We also identified the top 100 prospective customers as well as identified some key next steps. Here's a snapshot of our key results and findings. We used the decision tree method to develop our propensity model because it provided the highest accuracy, 69% of all the methods we have evaluated. We also used the model to identify the prospective customers that have a probability of 80% or higher that would accept an offering of the new product. A couple of the interesting insights we came across are that the important customer data are outcome, annual donations, and age. In addition, customers 18 to 25 and above 61 of the age have a 72% probability of accepting an offering of the new product. Christian will now walk you through the data and exploration that we performed.
Thank you, Ife. As data experts, we're very excited about these findings, but we know you might not be that familiar as we were. So we're going to guide you through like basic insights. The data set, we took like 4,000 customers from National Bank, and we used like 5 different data sets. National Bank's current customers, marketing results. Then we used household data from Axiom, that consulting that has been helping us. Then we used also household vehicle data, household credit data, and of course, National Bank's prospective customers, because those are the ones we're going to apply everything that we learned from the previous data sets. We basically joined all this data and divided into 2. A training set that helped us train our algorithm, our model, to identify the best variables, the variables that best explain who is a customer that will finally accept the car loan. And then we took another one that it's a validation set in which that algorithm that we trained, we wanted to see if it was really doing well in the real life quoted. If we look at the results, well, first, if we look at the data, we see that the outcome variable down there is in red. That's the percentage of missing values that we have for each variable. And even though 76% of the outcome variable is missing, it seems worth keeping it. Maybe clients who have accepted previous offers have a higher probability of also accepting new offers. Outcome means the outcome of the previous campaign. So if the outcome of the previous campaign was a success, then maybe it will be a success in the future. And that's why we decided to keep it. But let's look at the first results, like the initial results. So the key variables, we just like decided to analyze based on who accepted the offer. Like what are we talking about? Who is these people who really accept the offer? In terms of age, the average of the people who accepted the offer and the customers who did not accept the offer is very similar. However, you can see that there's a higher distribution, meaning that people who are older and also who are younger have a higher chance of accepting the offer of the car loan offer, right? In terms of car year, you can see that the average customer who accepted the offer has a slightly newer car. This could mean that people want to change their new car and keep it new rather than just like keeping their old car for a longer time. So maybe we're identifying those clients, and maybe this will be an important variable in predicting how it behaves in the future. And then the number of contacts, it's important for like management decisions. You can see that the customers who accepted the offer, on average, are called like 3 times. Maybe they're called like 10 times, one customer that accepted the offer. If you call them more than 28 times, then for sure you will have customers that will not accept the offer. Based on the data we have, it's not always 100% sure, but maybe it's not worth like calling them time and time and again. And maybe you're making a better use of your time by calling another customer. So if we keep looking at the data, and let's go to the next slide, yeah. This is the outcome variable that we were talking about previously. We can see that the customers who accepted the offer, of those who accepted the offer, around half of them also accepted the previous campaign, you know, and that's important as a variable, because we should start by calling those who have accepted previous campaigns. That's an interesting finding that we checked, and that should be analyzed further. Then if we take a snapshot at the age distribution, then we can see that the people who are younger and the people who are older are more likely to accept than those who are in the middle of the age distribution, right? You can see that the light blue color means that they accepted the offer, and it's mostly blue from 60 years onward, or 61, and then from 25 and below, you can see that there's a higher likelihood of acceptance. But let's look at the models, the actual models that we analyzed. Daniel is going to walk us through that.
Hi, everyone. So yeah, I'm going to walk you through 4 different models that we applied on your customer sets. We didn't want to bore you with too much analytical detail, but we thought it's important that you get a glimpse of what we've been working on. So the first method that we use to build an algorithm is called the KNN function. This one doesn't really look at variables in particular, but it just tries to find similar customers in your existing data set. And then for the new customers, it tries to match the customers that come close to them and give a new prediction whether they're going to accept the new offer or not. For the KNN, we got a pretty good accuracy of 69 or 0.69 accuracy, and going forward you will see that all the other models were pretty similar. However, there are a few more factors to consider when choosing. Going forward, we then also did a logistic regression model. This one does look at the variables of the existing customers, tries to see which variable contributes to their likelihood of accepting, and then pretty much plots that against the new customers that we looked at to give a prediction of whether they're going to accept or not. The third method that we used is called a classification tree. We also call it a decision tree. So whenever you have a new customer, you can pretty much drop them into your decision tree, and this model will tell you whether your customer is more likely to accept or not accept just by going down the tree and answering the questions that are being asked at the decision nodes. A boosted version of this decision tree is actually called a random forest. So in a random forest, we sample multiple times. We build multiple very small decision trees next to each other to just, in the best case, gain a higher accuracy and then make a prediction using our algorithm. So these were the 4 models, and Liz is now going to walk you through the decision tree that we picked in order to make a recommendation for you guys.
Hi, everyone. So first, we're going to look at the variables that we used. So the final variables analyzed. And out of these variables, the most important variables were the outcome, which again is the whether or not a previous offer was accepted, age, job, and recent balance. And we can now look at what the decision tree model looks like. The reason why we chose this decision tree as the model to use was first for the 69% accuracy, but also for the important visuals that it shows and more characteristics that it shows for the prospective customers. And this can be very beneficial when you're building marketing campaigns and reaching out to these customers. So starting at the top with the outcome, in this case, the variable specifically is outcome equals 0. And what that means is the equals 0 means that an offer was not accepted. So if that isn't the case, the decision tree will move to the right. So for those that did accept a previous offer, they have a 90% chance that they're going to accept, or 90% of those accepted this particular offer or will accept this particular offer. So that's really important, and one of the variables that we thought was really important to be on the high list of prospects. For those that did not accept a previous offer, we moved to age. And as we've learned previously, what this shows is that for those that are over the age of 61, 76% accepted. If you move, for those that are under the age of 61, we'll move on to job. And this case, the job cat B is what's called a dummy variable. It's a little bit tricky to understand. Really what you want to look for is that, and what we've given you is the negative 0.092 variable. And based on whether that is greater or less than, is going to be the deciding factor on the chances of accepting or declining. So if it's in this case, if it's less than that variable, they'll be more likely to decline. If it's more, we're going to move on to the second age variable. This age variable, again, is going to show that if it's the age is 30 or older than 30, there's a higher chance that they're going to decline. Under 30, ages under than 30, recent balance also becomes a factor. And for those folks under 30 with a recent balance of greater than 301, 65% will most likely accept. And then those with a balance less than 301 will more likely to decline. So in summary, outcome, really important if they had previously accepted an offer, the age, whether or not they're on the older side or the younger side, and then recent balance will play key roles in the acceptance. And lastly, we'll actually show you your final prospect list. So this list is the top 100 customers. It's listed in the order of most likely to accept. And as we've learned previously, those that are contacted 2 to 3 times as a max are going to be more likely to accept. So something to keep in mind as you move forward with the prospect list. And we hope that this is helpful and look forward to a successful campaign. Thank you very much.
In conclusion, we eagerly look forward to deploying the propensity model and evaluating the results of the 100 prospective customers that we identified. We're also looking forward to how the data insights we've gathered continue to evolve. As next steps, we'll send out a formal approval request to senior leadership team and look forward to the marketing team beginning the campaign process. We'll also partner with the marketing team to evaluate the results and fine-tune the model as needed. On behalf of Lizzie, Christian, Daniel, and myself, Ife, thank you for your time and the opportunity to work on this product. We look forward to utilizing the model to effectively optimize our business functions and exceed our business and product goals.